Beyond the orbit of Neptune, where sunlight is nothing more than a faint, distant flicker, lies one of the most mysterious regions of our solar system, the Kuiper Belt. This vast, icy frontier stretches billions of miles into the darkness, a graveyard of ancient relics left over from the birth of our cosmic neighborhood. But here's the thing, it's not just frozen rocks and forgotten debris. Hidden within this shadowy realm are objects so strange, so baffling, they defy everything we thought we knew about the outer solar system. Some spin erratically, tumbling through space like cosmic dice. Others gleam with surfaces so bright they reflect sunlight like mirrors, or drift in peculiar orbits that suggest unseen forces at work. And then there are those whose very existence shouldn't be possible, objects so massive, so oddly placed, they've sent astronomers scrambling for new theories. What makes the Kuiper Belt so fascinating isn't just its distance, it's the secrets it holds. Think of it as a time capsule, preserving clues about how planets formed, how our solar system evolved, and maybe even how life found its way to Earth. But every time we peer deeper into this frozen wilderness, it throws another curveball our way. Take, for example, the dwarf planet Haumea, a spinning, football-shaped world with rings, something we never expected to find out there. Or Arrokoth, the snowman-shaped object that looks like two cosmic bodies gently fused together in a slow-motion collision. These aren't just curiosities, they're pieces of a puzzle we're only beginning to assemble. That's why today we're diving into 25 of the most enigmatic objects lurking in the Kuiper Belt. From the bizarre to the beautiful, the inexplicable to the downright eerie, each one tells a story of chaos, of chance, and of the sheer unpredictability of the cosmos. Some might hold the keys to understanding our origins, others could rewrite the rules of planetary science, and a few, well, they might just leave you questioning what else is out there waiting to be discovered. So buckle up, we're about to journey into the frozen fringes of our solar system, where the ordinary gives way to the extraordinary, and every discovery raises more questions than answers. Are you ready to explore the unknown? The first stop on our journey through the Kuiper Belt's mysteries takes us to Arrokoth, formerly known as Ultima Thule, a name that literally means beyond the known world. And fittingly, this strange little world did just that. It pushed our understanding of the solar system's infancy into uncharted territory. When NASA's New Horizons spacecraft flew by in 2019, it gave us our very first close-up glimpse of a pristine Kuiper Belt object, untouched by the chaos of planetary formation. What we saw was astonishing, not a jagged, cratered relic, but a cosmic snowman, two distinct lobes pressed gently together like they'd been frozen mid-embrace. Scientists call this a contact binary, and it's a revelation. This delicate structure suggests Arrokoth formed from two separate bodies that drifted together so slowly they didn't even leave a dent. Imagine two snowflakes colliding in zero gravity, sticking without a scratch. That's the kind of gentle merger we're talking about, a far cry from the violent, high-speed crashes we once assumed built planetary building blocks. But here's the real puzzle. Its surface is suspiciously smooth. Where are the craters? Most ancient objects bear scars from eons of collisions, but Arrokoth looks like it's been wrapped in cosmic bubble wrap. Some researchers think its surface might be constantly refreshing, with volatile ices sublimating into space and settling back down like a slow-motion snowfall. Others speculate it's just been incredibly lucky, dodging debris in the sparsely populated Kuiper Belt. Then there's the color, a deep, uniform reddish hue, likely from organic molecules called tholins, cooked up over billions of years by cosmic radiation. This isn't just a tint, it's a chemical fingerprint offering clues about the ingredients that might have seeded life on Earth. But perhaps the most mind-bending detail is Arrokoth's age. This isn't just old, it's a fossil, a time capsule from the solar system's first few million years. The way its lobes fit together, the absence of distortion, everything points to a gentle, ancient origin story that challenges textbooks. If planets formed from violent collisions, how did something this delicate survive? The answer might rewrite how we think about everything from comets to Earth itself. Arrokoth isn't just a curiosity, it's a whisper from the dawn of the solar system, urging us to rethink everything we know. Pluto may have lost its planetary title, but it gained something far more intriguing, a front-row seat to the Kuiper Belt's greatest mysteries. Once the ninth planet, this icy world is now the crown jewel of the belt, revealing secrets that no textbook could have predicted. Take its most famous feature, that heart-shaped glacier known as Sputnik Planitia. This sprawling plain of nitrogen ice isn't just a geological quirk. It's a dynamic, ever-changing landscape that behaves almost like a lava lamp on a cosmic scale. Nitrogen glaciers creep across its surface, ice mountains rise and fall, and the entire basin might even be drifting, slowly tipping Pluto on its side like a ship weighted down by ballast. Then there's the real shocker beneath that frozen exterior. Scientists suspect a hidden ocean of liquid water. How does a world so far from the sun stay warm enough to harbor liquid? The answer might lie in radioactive decay deep in Pluto's core, or even the insulating power of exotic ices trapping heat like a cosmic thermos. If true, it raises a tantalizing question: could this distant, sunless realm have ever harbored life? But Pluto's greatest contribution might be the debate it ignited. Its 2006 demotion wasn't just bureaucratic, it forced astronomers to confront how little we truly understood about the outer solar system. Pluto's eccentric orbit, its family of moons, and its sheer complexity make it a bridge between planets and the smaller, stranger bodies of the Kuiper Belt. Some argue it should reclaim its planetary status, while others see it as the first of a new class of worlds, ice dwarfs rewriting the rules. What's undeniable is this: Pluto isn't just an endpoint. It's a gateway, proving that the Kuiper Belt isn't a frozen wasteland, but a vibrant, evolving frontier where even the smallest worlds can hold universe-shaking surprises. Eris doesn't just live in the shadows of the Kuiper Belt, it casts its own. Discovered in 2005, this icy renegade didn't just join the Dwarf Planet Club. It shattered our assumptions about what lurks in the solar system's frozen outskirts. First, there's its glare. Eris is one of the most reflective objects we've ever found, bouncing back 96% of the sunlight that hits it. That's brighter than freshly fallen snow on Earth. How its surface is likely a mirror-smooth slab of nitrogen and methane ice, constantly refreshed by a whisper-thin atmosphere that freezes and falls back like a slow-motion glitter storm. But the real shocker isn't what's on the surface, it's what lies beneath. Eris is denser than Pluto, packing more mass into a nearly identical size. That means it's not just a ball of ice, there's probably a rocky core buried deep inside, challenging the idea that Kuiper Belt objects are all lightweight relics. Some scientists think it might even have a subsurface ocean, kept liquid by radioactive decay or tidal heating from its moon, Haumea. Then there's the orbit, a path so tilted, it loops wildly above and below the solar system's flat plane like a cosmic roller coaster. Most planets and asteroids march in orderly formation, but Eris dances to its own rhythm. This bizarre trajectory hints at a turbulent past, maybe a gravitational kick from Neptune, or even a close encounter with another rogue world that sent it careening off course. And let's not forget its pop culture nickname, Sedna. Before getting its official mythological name, astronomers unofficially called it after the warrior princess from TV, a nod to its role as the rebel that forced us to rethink Pluto's status. Because here's the kicker, Eris isn't just another dwarf planet, it's the reason Pluto got demoted. When scientists realized Eris was actually more massive, the definition of a planet had to change, rewriting textbooks overnight. What does Eris tell us about the early solar system? Its rock and ice mix suggests it formed closer to the sun before being flung outward, a frozen refugee from a time when giant planets reshaped the cosmic landscape. Or maybe it's a messenger from even farther out, a visitor from the hypothetical Oort cloud, carrying secrets from the solar system's darkest edges. Either way, Eris isn't just a distant oddity. It's a disruptor, proving that even in the coldest reaches of space, the universe loves to surprise us. Makemake lurks in the Kuiper Belt like a cosmic chameleon, a world wrapped in mystery, its surface painted in shades of reddish-brown that shift with the seasons. Named after the creator god of Easter Island's Rapa Nui people, this dwarf planet carries a fitting legacy. It's a world that seems to defy creation myths of its own. Unlike Pluto, which boasts a hazy atmosphere and a complex dance of moons, Makemake stands eerily alone. No satellites circle it despite exhaustive searches. No wispy envelope of gases cloaks its frozen surface, just silence and a landscape of methane ice so stark it glows like a faded ember in the distant sunlight. What makes Makemake truly puzzling are those dark patches mottling its surface, irregular splotches that stand out against the bright methane plains like ink blots on parchment. Some scientists think they could be organic compounds, cooked by cosmic radiation into a tar-like residue over billions of years. Others suggest they're evidence of ancient cryovolcanoes, sputtering out sludge from depths we can't yet fathom. But here's the twist, these patches aren't randomly scattered. They cluster near Makemake's equator, as if something, maybe seasonal changes, maybe hidden geology, is actively shaping them. Then there's the missing moon. Almost every dwarf planet in the Kuiper Belt has at least one companion. Pluto has Charon, Haumea has Hioka and Namaka, even Eris has Dysnomia. But Makemake nothing. This absence is more than odd, it's a cosmic riddle. Did it lose a moon in some ancient collision, or did it never form one to begin with? The answer could rewrite how we understand the gravitational tug-of-war in the early solar system. And let's talk about that methane. On Pluto, methane interacts with nitrogen to create a dynamic atmosphere. On Makemake, it just sits there, frozen solid, as if the universe hit pause. Without an atmosphere to stir the pot, this world feels frozen in time, a snapshot of what the outer solar system looked like before chaos reshaped it. Yet even here, there are whispers of activity. Recent observations suggest that when Makemake swings closest to the sun, trace amounts of nitrogen might briefly vaporize, creating the faintest hint of a transient atmosphere. It's a heartbeat in the void, proof that even the quietest corners of the Kuiper Belt have stories to tell. So why does Makemake matter? Because it's a control experiment. By studying what it lacks, no atmosphere, no moons, we learn what makes its neighbors special. Its solitude forces us to ask, is it the odd one out, or are we just beginning to grasp how diverse these frozen worlds truly are? Every dark patch, every absent satellite is a clue, not just about Makemake, but about the forces that sculpted the solar system's last frontier. If you thought the Kuiper Belt had shown us all its quirks, Haumea begs to differ. This dwarf planet spins so fast it's turned itself into a cosmic egg. Picture a world whirling so violently that centrifugal force stretches it like taffy, flattening its poles and bulging its equator until it resembles a football more than a sphere. Haumea completes a full rotation in just 4 hours, making it one of the fastest spinning objects in the solar system. To put that in perspective, Earth takes 24 hours to spin once. Haumea races through 6 full days in that same time. If you stood on its surface, you'd witness a sunrise and sunset every 2 hours, the horizon curving unnaturally upward around you like you're trapped inside a funhouse mirror. But the real intrigue lies in what this frantic dance suggests about Haumea's past. Most astronomers agree this isn't just a fluke. That extreme spin, along with its elongated shape, points to a cataclysmic collision. Something massive must have sideswiped Haumea billions of years ago, hitting it with enough force to send it into this dizzying spiral, and the evidence doesn't stop there. Haumea has not one but two tiny moons, Hioka and Namaka, orbiting it like cosmic souvenirs from that ancient crash. These moons aren't just bystanders, their peculiar orbits hint at the violence that birthed them. Hioka, the larger moon, follows a nearly circular path, while Namaka weaves a chaotic, elliptical dance, almost as if they're still reeling from the impact that flung them into being. Then there's the glittering anomaly Haumea's surface. Unlike the muted tones of most Kuiper Belt objects, this world shines unusually bright, covered in crystalline water ice so pristine it reflects light like a cosmic disco ball. Normally, radiation over billions of years would turn ice amorphous and dull, but Haumea's ice is startlingly fresh, hinting at recent geological activity. Could cryovolcanoes be erupting beneath its crust, spewing fresh ice onto the surface? Or is the constant stretching and compressing from its rapid spin generating enough heat to keep the ice rejuvenated? But the collision theory raises even wilder possibilities. Some scientists speculate Haumea wasn't the only victim, that the same impact might have spawned an entire family of smaller objects sharing its orbit like celestial shrapnel. If true, it would make Haumea the anchor of a primordial crime scene, its moons and potential siblings all witnesses to a single, defining moment of destruction that reshaped this corner of the Kuiper Belt. Haumea isn't just another icy world. It's a testament to chaos, a reminder that even in the frozen quiet of the outer solar system, violence and motion shape the cosmos. From its impossible spin to its glowing surface, every clue whispers of a past too dramatic to ignore. And as we study it further, we might just uncover secrets that rewrite how we think about the turbulent youth of our solar system. Quaoar isn't just another icy world drifting through the Kuiper Belt. It's a rule breaker, a cosmic rebel that's forcing astronomers to tear up the textbook on ring systems. This dwarf planet, named after the creator god of the Tongva people, holds a distinction unlike any other. It boasts a ring that shouldn't exist. Not just any ring, one orbiting so far from Quaoar that it defies one of the most fundamental laws of planetary science, Roche's limit. For over a century, we've understood that rings form inside a boundary called Roche's limit, where tidal forces from the parent body are so strong they prevent debris from clumping into moons. Saturn's dazzling rings well within this limit, but Quaoar's ring laughs in the face of convention, sitting nearly twice as far out as it theoretically should. Imagine a hula hoop floating meters away from your waist instead of snug against it. That's how baffling this is. The particles in this ring should have coalesced into a moon eons ago, yet there they are, stubbornly circling in defiance of gravity's rules. So how does Quaoar pull this off? One theory suggests invisible shepherd moons might be herding the debris, their tiny gravitational nudges keeping the ring intact. Others propose that the particles are oddly bouncy, colliding like rubber balls instead of sticking together, creating a fragile equilibrium between dispersion and cohesion. But the wildest idea, that Quaoar's frigid temperatures hovering near -230 degrees Celsius have turned its debris into icy, elastic fragments that resist merging. If true, it means rings could form in ways we've never dreamed of, rewriting how we understand everything from Saturn's splendor to the birth of moons. And rings aren't Quaoar's only surprise. Telescopes have spotted hints of cryovolcanoes' ice-spewing vents that might still be active today. On most worlds, cryovolcanism requires internal heat, often from tidal flexing or radioactive decay. But Quaoar is small and lacks a nearby giant planet to tug on it, so where's the energy coming from? Some scientists speculate its odd, slow rotation once every 17.5 Earth days could create just enough friction to keep subsurface slush flowing. If confirmed, it would make Quaoar one of the coldest known worlds with ongoing geological activity, proving that even in the darkest reaches of the solar system, fire and ice find a way to coexist. What does all this mean for the bigger picture? Quaoar's rebellious ring and potential cryovolcanoes suggest that the Kuiper Belt isn't just a relic of the past, it's a dynamic laboratory where the rules are still being written. Every anomaly we discover forces us to reconsider how delicate the balance of forces shaping our solar system truly is. And if rings can exist where they shouldn't and volcanoes simmer where they can't, what other impossibilities are lurking in the dark, waiting to upend our understanding of the cosmos? Arrokoth lurks in the Kuiper Belt as Pluto's eerie cosmic twin, a world that mirrors the dwarf planet's orbit with eerie precision, yet does everything in reverse. Imagine a dance where two partners move in perfect sync, but always face opposite directions. That's Arrokoth and Pluto. Every time Pluto reaches its closest point to the Sun, Arrokoth swings out to its farthest and vice versa. Astronomers call this resonant orbit a celestial tug-of-war, locked in place by Neptune's gravitational pull. But here's the twist: Arrokoth isn't just a copycat. It's a study in contrasts, earning its nickname as the anti-Pluto for reasons that go far beyond orbital mechanics. Take its moon, Vanth. Unlike Pluto's massive companion Charon, which formed from a cataclysmic collision, Vanth is a puzzle wrapped in mystery. It's unusually large for a moon of its size, suggesting it might be a captured Kuiper Belt object rather than a born and raised satellite. Even stranger is the temperature mismatch between the two bodies. Arrokoth's surface hovers around -230°C, typical for this frozen realm, but Vanth, it's even colder. How does a moon orbiting so close to its parent world manage to stay chillier? Some scientists suspect Vanth's dark, charcoal-colored surface absorbs less sunlight than Arrokoth's brighter patches, acting like a cosmic insulator that locks in the cold. And speaking of those dark patches, Arrokoth's surface is a patchwork of contradictions. While much of it reflects sunlight like dirty snow, other regions are shockingly dark, as if smeared with cosmic tar. These could be deposits of complex organic molecules cooked by eons of radiation into a substance called tholins, the same stuff that gives Pluto its reddish hue. But there's a catch. Arrokoth's tholins seem concentrated in odd, irregular splotches, not evenly distributed. One theory suggests cryovolcanic activity might be dredging up dark material from beneath the ice, painting the surface in fleeting, ink-like streaks. Another possibility: ancient impacts unearthed layers of pristine ice, leaving behind a mottled terrain that tells the story of a violent past. What makes Arrokoth truly fascinating isn't just how it mirrors Pluto, it's how it deviates. The anti-Pluto moniker isn't just poetic, it's a clue. By studying these mirrored worlds, we're piecing together how the outer solar system's architecture took shape. Arrokoth might hold the key to understanding why some objects were flung into odd resonances, while others settled into quieter orbits. And with Vanth as its silent witness, this icy odd couple offers something rare, a controlled experiment written across the cosmos where tiny differences reveal universe-spanning truth. Gonggong drifts through the Kuiper Belt like a cosmic misfit, a world that refuses to follow the script. Named after the Chinese water god who brought chaos with floods and droughts, this dwarf planet lives up to its mythological namesake with every oddity it displays. First, there's its moody color palette, a deep reddish hue that makes it stand out like a rusty ember against the blackness of space. Most Kuiper Belt objects wear muted tones of gray or faded brown, but Gonggong's surface is stained with tholins, complex organic molecules forged by eons of radiation bombarding methane ice. Except here's the catch: Gonggong shouldn't have this much tholin. Telescopes reveal its surface is strangely depleted of methane, the very ingredient needed to create those reddish compounds. It's like finding a painting but no trace of the artist's brush, a paradox that has scientists scrambling for explanations. One theory suggests Gonggong's methane didn't vanish. It retreated. Beneath its icy crust, there might be a subsurface ocean locking away methane in liquid form, hidden from view. If true, it would join an elite club of ocean worlds, but with a twist. Unlike Europa or Enceladus, warmed by the gravitational pull of giant planets, Gonggong orbits alone in the frigid depths. How could an object this small and distant sustain liquid? The answer might lie in its sluggish rotation. Gonggong takes a leisurely 45 hours to complete a single spin, slow enough that radioactive elements in its core could generate just enough heat to keep water sloshing beneath the ice. Then there's the orbit, a chaotic path that swings wildly between 33 and 100 astronomical units from the Sun. Most dwarf planets follow predictable, elliptical routes, but Gonggong's trajectory looks like it was drawn by a toddler with a crayon. This irregularity hints at a turbulent past, possibly a gravitational kick from Neptune that sent it careening into exile. But the real shocker, Gonggong might not be traveling alone. Observations suggest a tiny moon, nicknamed Xiangliu after the nine-headed serpent companion of the water god, dances alongside it. This moon's orbit is bizarrely elongated, as if it's clinging to Gonggong by a thread, another clue that this system has survived cosmic violence. What makes Gonggong so captivating isn't just its defiance of expectations. It's the way it blurs the line between active and extinct worlds. Its surface shows signs of recent geologic activity, smooth plains that look resurfaced as if something erased its craters. Could cryovolcanoes be erupting beneath the ice, or is seasonal sublimation reshaping the terrain? Every answer we uncover only deepens the mystery. Gonggong isn't just another icy relic. It's a reminder that even in the solar system's darkest corners, chaos and creativity reign, and the universe still has a few surprises left up its sleeve. Sedna isn't just another distant object, it's a cosmic loner, drifting on an orbit so extreme it defies everything we know about the solar system's architecture. Picture a path so stretched out, so impossibly elongated, that it takes nearly 12,000 Earth years to complete a single loop around the Sun. At its closest approach, Sedna still lingers twice as far as Neptune. At its farthest, a staggering 930 times Earth's distance from the Sun, so remote that our star would appear as little more than a particularly bright dot in an endless black sky. This isn't just unusual, it's unprecedented. No other known object in the solar system follows such a stretched, solitary path. Most Kuiper Belt residents, even the eccentric ones, stay within the gravitational embrace of Neptune or the other giant planets. But Sedna, it's untethered, a cosmic rogue that seems to answer to no one. So how did it end up here? One leading theory sends chills down the spines of astronomers. Sedna's orbit might be the fingerprint of an unseen, massive planet lurking in the solar system's darkest reaches. Dubbed Planet 9 by researchers, this hypothetical world could be 10 times Earth's mass, orbiting hundreds of times farther out than Pluto. The math suggests its gravity might have yanked Sedna into this bizarre trajectory billions of years ago, like a hidden puppeteer tugging strings from the shadows. Not everyone's convinced. Some argue a passing star could have jostled Sedna into exile, but the evidence keeps mounting. If Planet 9 exists, Sedna might be the first breadcrumb leading us to its discovery. Then there's Sedna's crimson hue, a shade so deep it's among the reddest objects ever observed. This isn't just surface staining, it's a calling card from the outer limits. The color likely comes from tholins, organic sludge formed when cosmic radiation fries methane over eons. But here's the catch, Sedna's surface is too red even for the Kuiper Belt. Some scientists speculate its chemical makeup might bridge the gap between the belt and the Oort cloud, that hypothetical shell of icy debris surrounding the solar system. If true, Sedna could be a rare messenger from that uncharted frontier, offering clues about the raw materials that built our cosmic neighborhood. And let's talk about its isolation. Most objects in the Kuiper Belt have siblings, families of icy bodies with similar orbits. Sedna has none. It's a solitary traveler on a path that suggests it was either torn from its birthplace or never belonged to begin with. This loneliness makes it a Rosetta Stone for understanding the solar system's violent youth. Was Sedna flung outward by a close encounter with Neptune? Or is it a stolen relic captured from another star system entirely during the Sun's chaotic infancy? One thing's certain, Sedna doesn't play by the rules. Every oddity, its orbit, its color, its solitude paints a picture of a solar system far more dynamic and untamed than we ever imagined. Whether it's pointing us to Planet 9 or revealing secrets of the Oort cloud, this crimson wanderer is proof that the cosmos still holds mysteries too big for textbooks. And as we keep searching, who knows what other outliers are waiting in the dark, ready to rewrite the story of our celestial home. Ixion might be one of the faintest denizens of the Kuiper Belt, but don't let its dim glow fool you. This world is a cosmic paradox wrapped in mythology and mystery. Named after the legendary king condemned to an eternity bound to a flaming wheel in Greek myth, Ixion's celestial counterpart spins through the darkness with its own eerie secrets. What makes this distant object so fascinating isn't just its orbit, though that's bizarre enough, but the contradictions etched across its surface. Telescopes reveal a world seemingly split in two, one hemisphere slightly darker than the other, as if dipped in cosmic ink. This duality isn't just a visual quirk, it's a clue. The darker patches might be vast deposits of complex organic molecules, the same building blocks that gave rise to life on Earth. But here's the puzzle. How did such fragile compounds survive billions of years in the icy vacuum of the Kuiper Belt? Some scientists think Ixion's dark stains are tholins, the same reddish-brown sludge found on Pluto and other distant worlds, cooked up by relentless radiation bombarding methane and nitrogen ices. But there's a twist. Ixion's surface temperature hovers near -230 degrees Celsius, cold enough to freeze chemistry in its tracks. Yet somehow, chemical reactions persist, painting this world in hues that suggest hidden activity. Could Ixion's slow, wobbly rotation be exposing different patches of its surface to uneven doses of radiation, creating a patchwork of chemistry? Or is something more dynamic at play, cryovolcanic vents spewing fresh organic sludge onto the ice, like a cosmic etch-a-sketch resetting itself over eons? Then there's the orbit, a looping, lopsided path that defies expectations. Ixion dances in a precarious gravitational waltz with Neptune, tracing an elliptical route that hints at a turbulent past. Most objects locked in resonance with Neptune move like clockwork, their orbits predictable over millennia, but Ixion's path is just off. Some astronomers believe it might have been nudged into this irregular rhythm by a close encounter with another massive object, perhaps even a sibling now lost to the void. Others speculate its orbit is a fingerprint of Neptune's own migration billions of years ago, when the giant planet lumbered outward, scattering icy worlds like marbles in its wake. But the real intrigue lies in what Ixion's journey tells us about the solar system's hidden architecture. Its unusual orbit places it in an exclusive club of Plutinos, objects that share Pluto's peculiar resonance with Neptune. Yet unlike Pluto, Ixion shows no signs of geological drama. No atmosphere, no moons, no obvious scars of upheaval. It's as if this world froze in time, preserving a snapshot of the chaos that once ruled the outer solar system. So why does a faint, seemingly inert ball of ice matter? Because Ixion is a ghostly witness to forces we're only beginning to understand. Its dual-colored surface whispers of chemistry happening in the coldest, darkest corners of space. Its erratic orbit hints at gravitational battles fought long ago, and its very existence challenges us to ask, how many other cosmic sinners are drifting out there, their stories written in ice and shadow, waiting to be uncovered? Varuna spins through the Kuiper Belt like a cosmic pancake caught in a whirlwind, a world so stretched by its own rotation that it barely qualifies as a sphere. Imagine a ball of dough flattened between giant palms. That's Varuna's shape, bulging at the equator while squashed at the poles. This extreme elongation isn't just a curiosity, it's a telltale sign of a young, restless world. Clocking a rotation every 6 hours, Varuna whirls faster than most of its icy neighbors, a speed that would rip a more rigid object to shreds. Yet somehow, this fragile dance persists, held together by little more than the weak gravity of its own icy bulk. But the real mystery isn't just its shape, it's the eerie darkness cloaking its surface. Most objects in the Kuiper Belt reflect sunlight like dull pebbles, but Varuna's surface absorbs it, appearing darker than freshly poured asphalt. This isn't simply dirt or shadow, it's a global stain likely caused by a thick blanket of organic compounds called tholins. These molecules form when methane and nitrogen ices are zapped by cosmic radiation over eons, slowly transforming into a sticky, reddish-black sludge. The puzzle, Varuna's dark coat is uneven, blotchy, as if something is actively refreshing patches of brighter ice beneath. Could cryovolcanic plumes be erupting through the gloom, or is solar radiation selectively bleaching sections of its surface like cosmic sunlight fading an old photograph? Even more intriguing is what's happening beneath the surface. Varuna's breakneck spin should, in theory, be slowing down over time, gradually succumbing to the subtle tug of solar tides, the same gravitational forces that put the brakes on Earth's rotation. But recent observations suggest this slowdown might be happening faster than predicted, as if some unseen force is sapping its energy. One possibility: a hidden ocean sloshing beneath its icy shell, its currents dragging against the crust like an internal brake pad. If true, Varuna would join an elite group of ocean worlds, but with a twist. Unlike Europa or Enceladus, warmed by the gravitational kneading of giant planets, Varuna orbits too far for such heat. Its ocean, if it exists, would rely on entirely different physics, perhaps the decay of radioactive elements in its core or the latent heat of its own violent formation. Then there's the question of origins. How did Varuna end up spinning so fast in the first place? Most Kuiper Belt objects are leisurely tumblers, their rotations slowed by time and collisions. But Varuna's frantic whirl hints at a dramatic past, maybe a colossal impact that sent it into this dizzying spiral, or a gravitational kick from Neptune that scrambled its momentum. Whatever the cause, its shape and speed make it a celestial time capsule, preserving clues about the chaos of the early solar system. What does Varuna teach us? That even the quietest corners of the Kuiper Belt are dynamic laboratories, where worlds stretch, darken, and slow under forces we're only beginning to map. Its pancake shape defies expectations, its darkened surface whispers of hidden chemistry, and its slowing spin could rewrite what we know about tides in the frigid depths of space. Every rotation, every shadow is a silent challenge, daring us to look closer, to question deeper, and to wonder what other impossibilities might be spinning unnoticed in the dark. 2002 MS4 might not have the flashy reputation of some Kuiper Belt celebrities, but that's precisely what makes it so intriguing. It's a cosmic blank slate. This mid-sized world, roughly the diameter of West Virginia, floats through the darkness with an eerie uniformity, its surface painted in a monotonous beige that gives away nothing. No dark splotches, no bright patches, no scars from ancient impacts, just an unbroken sea of sameness stretching from pole to pole. In a region where most objects wear their histories like badges, 2002 MS4 is a sphinx, refusing to reveal its secrets. The first puzzle, its solitude. Objects this large in the Kuiper Belt almost always have moons. Pluto has Charon, Eris has dysnomia, even the smaller Haumea boasts 2 tiny companions. Yet despite years of searching, not a single satellite has been spotted circling 2002 MS4. This absence is more than odd, it's statistically improbable. One theory suggests it might have once had moons that were stripped away by gravitational encounters with Neptune, flung into the void like cosmic strays. Another possibility, its formation was unusually gentle, lacking the violent collisions that typically spawn moons in this chaotic region. without gravitational disturbances to tilt or reshape its orbit. 2002 MS4 could have drifted undisturbed for billions of years, a recluse in a neighborhood of socialites. Then there's that maddeningly uniform color. While most Kuiper Belt objects display mottled surfaces, evidence of seasonal changes, cryovolcanism, or radiation-darkened tholins, this world shows none of that. Its spectrum is as flat as a frozen lake, suggesting a surface either constantly refreshed by some unseen process or so ancient and inert that time has sanded it down to a featureless plain. Some scientists speculate micrometeorite impacts might be kicking up a fine dust that settles evenly, like cosmic snowfall erasing all texture. Others wonder if its slow rotation, taking nearly 19 hours to complete a single spin, creates a climate so stable that ices sublime and recondense in perfect equilibrium, leaving no room for variation. But the most tantalizing clue lies in what we don't see. 2002 MS4 reflects barely 12% of the sunlight that hits it, making it darker than freshly poured asphalt. Yet, unlike other dim objects, there's no telltale red tint from tholins. This suggests its surface chemistry is bizarrely inactive, as if frozen in stasis. Could its ices be locked in some ultra-stable configuration, resisting the radiation that transforms its neighbors? Or is it a time capsule from an earlier epoch, preserving primordial material untouched by the forces that reshaped the rest of the solar system? 2002 MS4 challenges us to rethink what ordinary even means in the Kuiper Belt. Its blandness isn't a lack of story, it's a story written in invisible ink, waiting for the right tools to reveal it. And as we peer deeper into the darkness, this unassuming world reminds us that sometimes the quietest objects have the loudest secrets. Salacia doesn't just orbit the sun, it carries its own cosmic companion, locked in a silent dance so precise it feels choreographed. This binary system, consisting of Salacia and its moon Actea, stands out in the Kuiper Belt not for its size but for its defiance of expectations. Most objects this far out are fluffy snowballs packed with ices and light enough to float in water. But Salacia, it's dense unnaturally so. Its bulk suggests a surprising secret. This world might be more rock than ice, a cosmic oddity lurking in the frozen fringes of the solar system. Actea, the smaller half of this pair, orbits Salacia at a leisurely pace, completing a full loop every 5.5 Earth days. Their gravitational embrace is so balanced that if you stood on Salacia's surface, Actea would hang motionless in the sky, a perpetual sentinel. But the real intrigue lies beneath the surface. Measurements suggest Salacia's density is nearly twice that of Pluto, hinting at a rocky core buried beneath a relatively thin shell of water ice. This composition mirrors terrestrial planets like Earth more than its icy Kuiper Belt neighbors, raising a tantalizing question. Did Salacia form closer to the Sun, only to be flung outward during the solar system's chaotic youth? One theory paints Salacia as a failed dwarf planet, a world that almost grew large enough to clear its orbit but stalled midway. Its rock-rich makeup could mean it was on the path to becoming something like Ceres, the asteroid belt's largest resident, before gravitational turbulence stranded it in the deep freeze. Alternatively, Salacia might be a survivor of a violent collision, its icy mantle blasted away long ago, leaving behind a dense, scrappy core. Actea could even be debris from that ancient impact, a moon born from catastrophe. Then there's the heat factor. Rock retains warmth far better than ice, and if Salacia's interior is as rocky as suspected, it might still harbor traces of radioactive decay, enough to power geologic activity beneath its frozen crust. Some researchers speculate that tidal forces from Actea's gentle tug could be flexing Salacia's core, generating just enough warmth to keep subsurface slush in motion. It's a long shot, but if true, Salacia would join the ranks of ocean worlds, albeit one forged from radically different materials. What makes this binary system truly remarkable is its defiance of categories. Too dense to be a typical Kuiper Belt object, too small to be a full-fledged dwarf planet, Salacia and Actea exist in a cosmic gray zone. They challenge our assumptions about how and where rocky bodies form, proving that the outer solar system isn't just a realm of ice, it's a graveyard of might-have-beens and nearly-wheres, each with a story etched in stone and frost. And as we study them further, we might just uncover truths that blur the line between inner and outer solar system, rewriting the narrative of how planets and their fragments find their place in the universe. Varda drifts through the Kuiper Belt like a cosmic puzzle, missing half its pieces, a world so faint and irregular that it defies simple explanations. Unlike the spherical dwarf planets dominating this region, Varda's shape resembles a lumpy potato, its surface scarred by unseen forces. But the real mystery isn't just its form, it's the chemistry etched across that uneven terrain. While most objects its size boast surfaces rich in methane or nitrogen ices, Varda's spectrum reveals something darker, older, almost primal. Infrared scans detect traces of water ice mixed with something far rarer, complex carbon chains, the kind of organic sludge that shouldn't survive billions of years in the deep freeze. Then there's Ilmare, Varda's silent companion. This moon orbits so far out, over 4,600 miles away, that from Varda's surface it would appear as little more than a dim star. Most moons in the Kuiper Belt cling close to their parents, locked in tight gravitational embraces. Ilmare's loose orbit suggests a turbulent past, perhaps a capture event where Varda snatched it from the void. Yet the two share a spectral signature, hinting they might be siblings after all, born from the same ancient collision that left Varda misshapen. What could explain Varda's oddball chemistry? One theory points to its slow, wobbly rotation. Unlike Haumea's dizzying spin or Pluto's steady rhythm, Varda takes a sluggish 22 hours to complete a turn, exposing patches of its surface to uneven doses of cosmic radiation. Over eons, this might have selectively cooked certain regions, leaving behind a patchwork of organic-rich zones and pristine ice, another possibility. Cryovolcanic vents belching primordial ooze from deep within, smearing the surface with relics from the solar system's birth. The most tantalizing clue lies in Varda's darkness. It reflects less than 10% of sunlight, making it one of the least reflective objects ever measured. This isn't just dirt, it's a global shroud, likely thickened by those carbon chains knitting together into a tar-like blanket. Some researchers speculate this darkness acts like a cosmic insulator, trapping heat from radioactive decay deep inside. If true, Varda could harbor pockets of liquid water trapped between layers of ice and rock, a hidden haven in a realm where liquid shouldn't exist. Varda and Ilmare aren't just oddities, they're time machines. Their irregular shapes and puzzling chemistry suggest they might be among the oldest intact remnants of the solar system's infancy, worlds that avoided the collisions and migrations that reshaped their neighbors. Every ridge, every spectral line is a whisper from a time before planets took their modern forms. And as we study them further, we might just uncover secrets about how the building blocks of life survived and thrived in the coldest corners of space. Deep in the Kuiper Belt's frozen expanse, one object moves with glacial patience so slowly that astronomers initially nicknamed it DD, short for distant dwarf. Officially catalogued as 2014 UZ-224, this world takes an astonishing 1,130 Earth years to complete a single orbit around the Sun. At its current distance, sunlight takes nearly 14 hours to reach its surface, and temperatures hover near -240 degrees Celsius, just 30 degrees above absolute zero, the coldest possible temperature in the universe. What makes DD remarkable isn't just its sluggish pace, it's how we found it. Unlike most Kuiper Belt objects discovered through targeted searches, DD popped up unexpectedly in data from the Dark Energy Survey, a project designed to map the expansion of the cosmos. Its faint signature was buried in observations meant to study galaxies billions of light-years away, a cosmic needle in a haystack of dark energy calculations. When astronomers first spotted its dim, crawling motion, they weren't even sure it belonged to our solar system. The nickname DD stuck as a playful placeholder, a nod to both its distant location and the initial uncertainty surrounding its origins. But the real surprise came when researchers pointed the Atacama Large Millimeter Array toward DD. The thermal emissions it detected revealed an object far larger than expected, roughly 635 kilometers in diameter, making it potentially the third largest known object in its region after Pluto and Eris. This raised eyebrows. How could something this sizable evade detection for so long? The answer lies in its darkness. DD reflects just 13% of the sunlight that hits it, its surface likely coated in a thick blanket of primordial gunk, a mix of organic compounds and radiation-battered ices that have barely changed since the solar system's birth. Then there's the question of its orbit, a lopsided path that swings from 38 to 180 astronomical units from the Sun. Unlike most Kuiper Belt objects nudged by Neptune's gravity, DD's trajectory suggests it might be a detached object influenced by forces we've yet to pinpoint. Some speculate it could have been slingshotted outward by a close encounter with an unseen planet, or perhaps it's a visitor from the inner Oort cloud, drifting inward on a journey that spans epochs. What DD lacks in flashiness, it makes up for in secrets. Its sluggish movement near absolute zero temperatures and in-sky surface make it a time capsule from an era when the planets were still taking shape. And as we study it further, this distant dwarf might just reveal how the solar system's outermost builders, those frozen, half-formed worlds, escaped the chaos of their youth to become the quiet sentinels of the deep. 2007 or 10 earned its nickname Snow White from astronomers who first spotted it, a playful nod to what they assumed would be a bright, icy world glinting in the distant dark. But the universe loves a good prank. Instead of the frosty purity its name suggests, this dwarf planet turned out to be one of the Kuiper Belt's reddest objects, its surface stained a deep, rusty hue like Martian dirt soaked in old blood. The irony isn't lost on scientists. Snow White isn't snow, and it's certainly not white. So what paints this world in such vivid tones? The answer lies in a toxic cocktail of chemicals called Tholen's complex organic molecules that form when methane and nitrogen ices get bombarded by cosmic radiation over billions of years. Think of it as nature's slow-cooked recipe. Take frozen gases, zap them with endless particle collisions, and wait until they polymerize into a sludge so dark and red it could pass for cosmic barbecue sauce. But here's the twist. 2007 or 10's Tholens aren't just superficial stains. They're layered thick enough to suggest something's replenishing them, either through cryovolcanic upwellings or seasonal shifts that churn fresh ice to the surface. Then there's the languid spin. While most Kuiper Belt objects pirouette through space in a matter of hours, Snow White takes a leisurely 45 hours to complete a single rotation, an eternity by celestial standards. This sluggishness hints at an unseen partner. Many slow rotators are tidally locked to moons, their spins dragged down by gravitational tug-of-wars. Yet despite exhaustive searches, no satellite has been found. Some researchers argue the missing moon might have been there once, stripped away by an ancient collision. Others propose a more tantalizing possibility, that 2007 or 10's rotation is slowed by an ultra-thin, transient atmosphere. Imagine this: as the dwarf planet edges closer to the Sun during its elongated orbit, feeble sunlight might vaporize patches of surface ices, creating a temporary shroud of nitrogen or methane gas. Too wispy to be seen directly, this ghostly envelope could still exert enough drag to break the world's spin like a hand pressed against a spinning top. If confirmed, it would make Snow White part of an elite club, one of the rare Kuiper Belt objects with detectable atmospheric activity, joining Pluto and Eris in defying the notion that the outer solar system is a static, frozen graveyard. What emerges from these contradictions is a portrait of a world caught between extremes: red yet once thought white, sluggish yet possibly dynamic, solitary yet bearing scars of lost companions. Every new observation peels back another layer of irony, proving that in the Kuiper Belt, even the quietest objects are hiding radical secrets. And as we study Snow White further, we're reminded that in astronomy, first impressions are often just the opening act of a much weirder story. 2002 AW197 lurks in the Kuiper Belt like a cosmic contradiction, a world so dark it absorbs nearly all sunlight, yet somehow radiates unexpected warmth. Most objects this far from the sun are deep frozen relics, their surfaces chilled to temperatures barely above absolute zero. But 2002 AW197 defies expectations, registering a thermal signature just warm enough to raise eyebrows. This isn't just a minor discrepancy, it's a full-blown mystery wrapped in frozen carbon-rich sludge. The first clue lies in its size, roughly 700 kilometers across, making it one of the larger residents of the Kuiper Belt. Objects this massive usually retain heat from their formation, the residual energy of countless collisions during the solar system's violent youth. But here's the puzzle: 2002 AW197's warmth isn't evenly distributed. Infrared scans reveal patchy hotspots, areas where temperatures spike unpredictably, as if something beneath the ice is stirring. Could this be the faint heartbeat of geologic activity, a sign that this distant world isn't as dead as it appears? One theory points to radioactive decay. Like a nuclear battery buried in its core, heavy elements like uranium and thorium could be slowly breaking down, generating just enough heat to keep the interior restless. If true, it would mean 2002 AW197 is more than a frozen fossil. It's a dynamic world with layers of slushy ice and maybe even pockets of liquid water trapped between them. Another possibility: tidal flexing from a hidden moon. While no satellite has been spotted yet, the gravitational tug of an unseen companion could be kneading the dwarf planet's interior, generating friction and warmth like clay squeezed between hands. Then there's the surface, a tar-black expanse that reflects less than 5% of sunlight, one of the darkest surfaces known in the solar system. This isn't ordinary dirt. It's likely a thick blanket of complex organic molecules, the same primordial goop that might have seeded life on Earth. But unlike other dark Kuiper Belt objects, 2002 AW197's crust shows strange cracks and fissures, as if something is pushing up from below. Cryovolcanoes, nitrogen geysers, or simply the slow-motion stress of a cooling interior. The most tantalizing possibility is that we're witnessing a cosmic balancing act. 2002 AW197 might exist in a rare sweet spot, large enough to hold onto formation heat, but small enough that it hasn't fully frozen solid. Its warmth could be the last gasp of a cooling world, or the quiet hum of something still alive beneath the ice. Either way, this dark, enigmatic orb reminds us that even in the farthest reaches of the solar system, cold doesn't always mean dead, and sometimes the most unassuming objects hide the hottest secrets. 2005 RN43 hides in plain sight, a shadowy, almost dwarf planet lurking at the solar system's edge, so perfectly spherical it teeters on the brink of planethood. Unlike the misshapen rubble populating much of the Kuiper Belt, this world boasts a shape smoothed by its own gravity, a telltale sign it once harbored enough mass to pull itself into near-perfect harmony. Yet for all its elegance, 2005 RN43 refuses to shine. Its surface reflects a meager 5% of sunlight, making it one of the darkest objects in its class, a cosmic stealth bomber drifting through the void. What cloaks this world in such profound darkness? The leading suspect is a thick, global tar pit of primordial organic gunk, the same Tholen-rich sludge staining Pluto and other distant worlds. But here's the twist: 2005 RN43's darkness is unusually uniform, lacking the mottled patches seen on similar bodies. Some scientists speculate its surface might be constantly refreshed by cryovolcanic activity, belching fresh blackened material that spreads like ink in water. Others argue it's simply ancient, a time capsule so undisturbed that radiation has cooked its ices into a homogeneous carbon crust over billions of years. Then there's the orbit, a lopsided path that swings from 34 to 51 astronomical units from the Sun. This elliptical route hints at gravitational turbulence in the solar system's youth, likely a close encounter with Neptune or another massive disruptor. But the real anomaly is its inclination, tilted 13 degrees off the solar system's flat plane, as if knocked askew by a cosmic sideswipe. Most objects this large follow orderly paths. 2005 RN43's deviation suggests it might have been yeeted outward during the giant planet's chaotic migration 4 billion years ago. The most tantalizing clue lies in what it lacks. Despite its size, roughly 680 kilometers in diameter, no moon has been detected. For a world this substantial, that's statistically bizarre. Did it lose a companion to gravitational theft, or was it born solitary, a rare monolithic survivor of the Kuiper Belt's violent infancy? Every absence speaks volumes, painting this shadowy sphere as both an outlier and a key to understanding how the solar system's architecture took shape. 2005 RN43 isn't just another icy relic. Its darkness whispers of chemistry frozen in time. Its orbit carries scars of ancient upheaval, and its lonely perfection challenges the very definition of a dwarf planet. As we study it further, we might just uncover whether it's a failed planet, a displaced wanderer, or something even stranger, a silent witness to forces we've only begun to fathom. 2004 GV9 gleams like a cosmic disco ball in the darkness of the Kuiper Belt, a world so bafflingly reflective it bounces back nearly 50% of the sunlight that touches it. Most objects out here are dim and cratered, their surfaces weathered by eons of cosmic bombardment. But 2004 GV9, it's pristine. Telescope images reveal a smooth, almost polished appearance, as if some invisible hand regularly buffs away the scars of time. This isn't just unusual, it's unprecedented. The leading theory, cryovolcanic facelifts. Imagine geysers of slushy ice erupting from deep beneath the surface, spreading a fresh layer of frozen material that hardens into a glossy sheen. It's like nature's own Zamboni machine, resurfacing the terrain in an endless cycle of renewal. But here's the catch: cryovolcanism usually requires internal heat, and at this distance from the Sun, 2004 GV9 shouldn't have enough energy to power such activity. Unless, of course, its core is laced with radioactive elements, simmering quietly like a nuclear furnace beneath the ice. Then there's the wild card, its composition. Some researchers argue the reflectivity might come from exotic ices, not just water, but methane or nitrogen frozen into bizarre crystalline structures that act like natural mirrors. On Pluto, sunlight transforms methane into dark tholins over time, but 2004 GV9's surface seems resistant to this staining. Could its ices be purer, or is some unseen process actively scrubbing away the discoloration? The absence of craters deepens the mystery. Impact scars are the Kuiper Belt's history books, each one a record of collisions spanning billions of years. A craterless surface suggests either incredible luck dodging every cosmic bullet or constant renewal. But if it's the latter, what force is powerful enough to keep this world perpetually pristine? 2004 GV9 isn't just another icy relic. It's a challenge, a reminder that even in the frozen fringes of the solar system, the rules are still being written. Whether it's powered by hidden geology, cloaked in rare materials, or simply defying expectations through sheer improbability, this dazzling enigma proves that sometimes the universe's quietest corners shine the brightest. 2003 AZ84 isn't just another icy world drifting through the Kuiper Belt. It's a cosmic clockwork, a binary system where a dwarf planet and its moon move in such perfect harmony they could pass for celestial gears. The star of this duo is the primary body, a roughly 500-mile-wide orb, but the real showstopper is its companion, a moon named Quaoar, tracing an orbit so circular it defies the odds. Most moons in this region follow elliptical, lopsided paths, shaped by gravitational chaos over billions of years. Quaoar's near-perfect circle suggests something extraordinary, a relationship so stable it survived the solar system's turbulent youth unscathed. What keeps this orbit so precise? One theory points to tidal locking, the same gravitational embrace that keeps Earth's moon forever facing us. But here's the twist. Quaoar's circular path hints that 2003 AZ-84's gravity field is unusually even, lacking the irregularities that typically distort satellite orbits. This smoothness might mean the dwarf planet's interior is more uniform than expected, possibly layered like an onion with no dense, lopsided core to tug its moon off course. Alternatively, Quaoar could be a relative newcomer captured so gently that it slipped into this flawless rhythm without the usual gravitational drama. Then there's the methane mystery. Like Pluto, 2003 AZ-84's surface is dusted with methane frost, but with a curious pattern, brighter patches near its poles that seem to shift over time. These aren't static stains, they're evidence of seasonal change, a revelation that stunned astronomers. How does a world this far from the sun, where temperatures hover near -240 degrees Celsius, experience seasons? The answer lies in its tilt. Unlike Earth's modest 23-degree lean, 2003 AZ-84 might wobble dramatically on its axis, exposing its poles to decades of continuous sunlight or darkness during its long orbit. When the sun finally graces a frozen pole, trace amounts of methane ice could sublimate, migrating to the opposite pole like a slow-motion weather cycle. But here's the real kicker. These frost cycles aren't just meteorological quirks, they're chemical laboratories. Methane, when zapped by cosmic radiation, can transform into tholins, the reddish organic compounds that paint so many Kuiper Belt worlds. If 2003 AZ-84's frost is on the move, its surface chemistry could be constantly refreshing, creating a patchwork of young, bright ice and ancient, darkened sludge. This would make it one of the few places where we can witness the solar system's primordial ingredients actively reacting, like a time lapse of the processes that might have seeded life's building blocks on Earth. The binary system's harmony and its frosty rhythms offer something rare, a glimpse into the delicate balance of forces shaping the Kuiper Belt's climate. By studying how Quaoar's orbit remains so steady, we learn how moons survive in this chaotic realm. By tracking its methane migrations, we uncover how even the faintest sunlight can breathe life into frozen worlds. Together, they whisper a truth. Out here in the dark, where time moves slower and cold runs deeper, the universe still finds ways to keep things in motion. 1996 TL66 wasn't just another icy rock. It was a trailblazer, the first of its kind to reveal that the Kuiper Belt wasn't the end of the solar system's story. Discovered decades before most of its scattered disk siblings, this distant wanderer forced astronomers to confront a glaring truth. Our models of the outer solar system were missing something big. Its orbit alone reads like a cosmic rebellion, a lopsided, high-inclination path that swings from 35 to 130 astronomical units, carving a wild loop far above and below the orderly plane where planets dutifully circle. If most Kuiper Belt objects are commuters stuck in traffic, 1996 TL66 is a motorcycle weaving between lanes, oblivious to the rules. This chaos isn't random, it's a clue. The scattered disk, the sparsely populated region where 1996 TL66 resides, is a gravitational dumping ground, a place where objects exiled by Neptune's turbulent youth now drift in chaotic orbits. Traditional models assumed Neptune's migration outward was smooth, like a glacier inching forward. But 1996 TL66's extreme trajectory suggests something far more violent. A series of gravitational kicks, perhaps even a dance with an unseen planetary sibling that once shared the outer solar system. Imagine Neptune as a bull in a cosmic china shop, its gravitational horns flinging icy worlds into the abyss. The real puzzle lies in the timing. 1996 TL66's orbit is too stretched, too tilted, to fit neatly into early simulations of Neptune's migration. Some astronomers argue this means the giant planet's journey wasn't a steady crawl but a staccato series of jumps, propelled by close encounters with other massive bodies. Others propose an even wilder idea, that 1996 TL66 might be an interloper, a refugee from the inner Oort cloud nudged inward by a passing star during the solar system's infancy. What makes this object so invaluable isn't just its strangeness, it's its role as a benchmark. As one of the first scattered disk objects ever catalogued, it set the standard for understanding how gravitational chaos shaped the solar system's fringes. Every new discovery in this region, from Eris to Sedna, owes a debt to this pioneer. And as we study its path further, we might just uncover whether it's an outlier or a harbinger, proof that the outer solar system's history was written in disruptions, not orderly steps. 1996 TL66 doesn't just challenge textbooks, it dares us to rewrite them. 1995 SM55 spins through the Kuiper Belt like a cosmic top set to overdrive, completing a full rotation every 4 hours, so fast that its own centrifugal force has stretched it into an elongated shape resembling a squashed football. Most objects this size settle into more relaxed spins over billions of years, their rotations slowed by gravitational tides or collisions. But 1995 SM55 refuses to slow down, whirling with enough energy to fling surface material into space if it spun any faster. This breakneck dance raises two burning questions. What's keeping it in motion, and why hasn't it torn itself apart? One clue lies in its unusual composition. While most Kuiper Belt objects are icy rubble piles, spectroscopy suggests 1995 SM55's surface is unusually rich in metals, possibly even laced with nickel or iron. This could mean one of two things. Either it's the remnant core of a much larger body that was shattered by impacts, stripped down to its dense metallic bones, or it formed in a region of the early solar system where heavy elements were more abundant, making it a rare metallic refugee in an icy realm. Then there's the mystery of its shape. Such extreme elongation typically points to a violent past, perhaps a catastrophic collision that sent it into this dizzying spiral. But there's another, even stranger possibility, an unseen moon. Tidal forces from a hidden companion could be tugging on 1995 SM55, keeping it off balance like a dancer gripped by an invisible partner. If such a moon exists, it would need to orbit at just the right distance to maintain this gravitational tango without being torn apart or drifting away. The stakes are higher than they seem. If collisions shaped this world, it suggests the Kuiper Belt was once a far more violent place, with impacts energetic enough to strip away icy mantles and leave behind metallic cores. But if tides from a moon are to blame, it hints at a delicate gravitational ballet we've barely begun to understand. Either way, 1995 SM55 defies the quiet, frozen stereotype of the outer solar system. It's a reminder that even in the darkest reaches of space, momentum reigns, and sometimes the universe's most enigmatic objects spin too fast to be ignored. 1999 CD-158 doesn't orbit the Sun so much as it cartwheels around it, a high-flying rebel on a path so steeply tilted, it practically loops over the solar system's north and south poles. While most objects in the Kuiper Belt stick close to the ecliptic plane, this icy maverick climbs to an astonishing 30 degrees of inclination, as if it's trying to escape the cosmic neighborhood altogether. Such extreme angles are rare, and they don't happen by accident. Something or someone gave this world a gravitational shove strong enough to knock it sideways. The prime suspect, Planet 9, the hypothetical giant lurking in the outer darkness. If this undiscovered world exists, its gravity could be playing cosmic pinball with objects like 1999 CD-158, yanking them into bizarre orbits over millennia. The math is compelling. Simulations show Planet 9's pull could explain not just this object's tilt, but also the peculiar clustering of other high-inclination Kuiper Belt residents. It's as if an invisible hand is herding them into this strange celestial chorus line. But there's another, equally thrilling possibility: ancient chaos. Billions of years ago, Neptune's migration outward sent shockwaves through the outer solar system, scattering icy worlds like billiard balls. Some may have been catapulted into high-inclination orbits during close encounters, their paths forever altered by gravitational slingshots. 1999 CD-158 could be a survivor of that era, a frozen relic of the solar system's most violent remodeling project. What makes this object so fascinating isn't just its odd orbit, it's the pristine time capsule it represents. High-inclination objects often escape the collisions that batter their flat-orbiting cousins, preserving ancient surfaces untouched by later cosmic traffic. If we could sample 1999 CD-158's ices, we might be tasting material unchanged since the dawn of the solar system. Yet the biggest mystery remains unsolved. Is this tilted traveler a pawn of Planet 9, or a fugitive from Neptune's turbulent past? Each hypothesis paints a different picture of the outer solar system's hidden architecture, one where either a lurking giant or long-vanished chaos holds the keys. Until we find more clues, 1999 CD-158 will keep spinning its enigmatic dance, a silent question mark against the stars. 2000-0067 isn't just another distant rock. It's a cosmic daredevil threading a needle through the solar system's gravitational minefield on a 12,000-year orbit so stretched, so audacious, it defies the very odds of celestial mechanics. At its closest, it swoops within Neptune's orbit, closer to the Sun than Pluto ever ventures. At its farthest, it retreats to a staggering 1,060 astronomical units, so remote that the Sun shrinks to a pinprick. This isn't just an orbit, it's a high-wire act, a trajectory so precarious that astronomers initially struggled to believe it could remain stable over cosmic time. What makes 2000-0067 so baffling isn't just its extreme path, it's how it survives. Objects crossing Neptune's orbit typically meet one of two fates. They're either swallowed by the giant planet's gravity or hurled into exile. Yet somehow, this icy maverick has danced between the raindrops for billions of years, sidestepping catastrophe with the precision of a cosmic ballet dancer. The secret, a delicate resonance with Neptune, where its orbital rhythm syncs up just enough to avoid direct encounters. Think of it as gravitational Parker using Neptune's own pull as a slingshot to keep ahead of disaster. But here's the twist: simulations suggest this balancing act shouldn't last. Given enough time, Neptune's gravity should destabilize such orbits, ejecting their occupants into interstellar space or swallowing them whole. That 2000-0067 persists hints at gaps in our understanding. Some scientists speculate it might be an immigrant captured from another star system during the Sun's galactic infancy. Others propose unseen forces, perhaps the gentle nudge of Planet 9's hypothesized gravity, acting as a cosmic stabilizer, shepherding it along this improbable path. Then there's the surface. Unlike the reddish hues of many Kuiper Belt objects, 2000-0067 wears a muted gray, suggesting a crust stripped of volatile ices by its repeated close brushes with the Sun's warmth. Each perihelion passage might trigger a fleeting outburst, as buried gases briefly vaporize before refreezing into an ever-thickening armor of inert dust. If so, it's not just a survivor, it's a shapeshifter, its appearance morphing with every lap around the solar system. What lessons does this orbital rebel hold? For starters, it's a testament to chaos and resilience, proving that even in a realm ruled by gravity's iron grip, exceptions exist. Its very existence challenges models of solar system evolution, suggesting that the outer reaches are far more dynamic and far stranger than we ever imagined. And as we track its lonely voyage further, we might just uncover whether it's a fluke or a harbinger proof that the universe loves an underdog, even in the frozen dark. Far, far out isn't just a name, it's a statement. Perched a staggering 140 astronomical units from the Sun, this tiny, faint speck currently holds the title of the solar system's most distant known object. To put that into perspective, it's 3.5 times farther out than Pluto, so remote that sunlight takes nearly 20 hours to reach its frozen surface. At this distance, the Sun is nothing more than the brightest star in an endless black sky, its warmth reduced to a whisper too faint to melt even the most volatile ices. What makes far, far out extraordinary isn't just its distance, it's how we found it. Unlike the calculated searches that uncovered Pluto or Eris, this record breaker was stumbled upon almost by accident. Astronomers were tracking another distant object when they spotted a blurry smudge drifting across their images, a ghostly afterthought in data meant for something else. The fact that something so faint and far-flung could be detected at all is a testament to how far our technology has come. But here's the chilling implication: if we can find one, how many more are lurking beyond the edge of our maps? Size is another enigma. Initial estimates suggest far, far out is roughly 400 kilometers across, small enough to fit inside the state of Arizona, yet massive enough to hint at an unseen population of similar worlds. Its dim glow suggests a surface darker than coal, likely coated in primordial organic gunk baked by eons of cosmic radiation, but the real puzzle is its orbit. Unlike Sedna or other distant objects with elongated paths, far, far out's trajectory is still being pieced together. Early clues suggest it might be gravitationally detached, meaning no planet currently guides its motion. Instead, it could be a relic from an era when Neptune's violent migration hurled icy worlds into the void, leaving them to wander like cosmic castaways. Then there's the bigger picture. Far, far out isn't just a curiosity, it's a scout. Its existence hints at legions of undiscovered objects in the solar system's twilight zone, each a frozen time capsule from the dawn of planet formation. Some might be even farther out, nudging the boundaries of the Oort cloud. Others could share its darkness, their surfaces untouched by sunlight for billions of years. Every new discovery in this realm forces us to redraw the solar system's borders, pushing the frontier deeper into the unknown. But perhaps the most tantalizing question isn't where far, far out is, it's what it's made of. At these distances, ices behave strangely and chemistry unfolds at a glacial pace. Could its surface preserve molecules from the solar system's infancy, unchanged since the days when planets were mere swirling dust? Or does it hide secrets we haven't even thought to look for? For now, it remains a pixelated mystery, a single point of light against the void. Yet in that faint glow lies a challenge. The universe is always bigger, always stranger than we imagine, and the Kuiper Belt's darkest corners still have stories left to tell. From football-shaped worlds spinning faster than a blender to crimson wanderers drifting untethered in the void, the Kuiper Belt has served up cosmic mysteries that rewrite the rules of planetary science. Who could forget Haumea tumbling through space so violently it stretched into an egg, or Quaoar's impossible ring floating twice as far as gravity should allow? We've met worlds with surfaces darker than charcoal yet oddly warm, dwarf planets hiding liquid oceans beneath icy crusts, and binary systems dancing in such perfect sync they defy billions of years of chaos. Even Pluto, the belt's poster child, surprised us with glacier-shifting seasons and a heart-shaped plain that might tip the entire planet on its side. But here's the humbling truth: we've barely scratched the surface. For every mystery solved, like Arrokoth's gentle snowman shape revealing how planets truly form, a dozen more emerge. Why does Sedna orbit like a cosmic exile? What paints snow-white blood red while 2004 GV9 gleams like a mirror? Could far, far out be the first of countless unseen worlds lurking in the darkness? Each question uncovers another layer of the solar system's hidden story. The next chapter is already being written. Proposed missions like the Interstellar probe aim to pierce the Kuiper Belt's depths, while next-gen telescopes could spot objects currently invisible to us. Every discovery reminds us this isn't just a frozen graveyard. It's a dynamic frontier where rings defy physics, oceans hide in the unlikeliest places, and even the quietest worlds hold secrets that reshape our cosmic identity. So now it's your turn. Which of these 25 enigmas left you stunned? The spinning top of 1995 SM55, Makemake's eerie solitude, or the possibility that Planet 9's gravity might be herding worlds like 1999 CD158 into bizarre orbits. Drop your pick in the comments and let's keep unraveling the Kuiper Belt's darkest, coldest, and most astonishing mysteries together.